My name is Emily, and today I will focus on function operations. In doing so, I will teach you how to find the sum, difference, product, and quotient of various functions, and explain what a domain restriction is and why they're not legal in math.
What is a function?
A function is a rule which operates on an input and an output. When we see f of x, we know that f of x is the same exact thing as y, but f of x is referring to how exactly we would evaluate a function for the value of, in this case, x. There are two terms we will focus on in functions, the domain and the range. The domain is the set of all x values that work in a function. The range is the set of all the outputs of a function, or in other words, the y values.
What about domain restrictions?
Domain restrictions occur when there is a negative under the radical or the denominator is equal to 0. Let's say we had the problem f of x equals 1 over x minus 2. First, what you would do is you would set the denominator to 0. X minus 2 equals 0. We'd add 2 to both sides. And we would get x cannot be 2. If we were to plug 2 back in here, we would get 2 minus 2 equals 0, and we can't have that. This will give us a denominator of 0, and that's undefined. The same thing will apply with the radical, since we don't want a negative radicand, and that will be an imaginary number. Here, we have f plus g of x. Let's say you're given f of x is equal to 2x plus 6 over x plus 1, and g of x is equal to 2x squared minus 2 over x plus 3. We want to add f plus g. Here's our f, here's our g. So we set it up like this. 2x plus 6 over x plus 1 plus 2x squared minus 2 over x plus 3. What we want to do now is find the least common denominator and multiply by what we need to get the LCD over itself. Since we want to get the LCDs, we're going to multiply this side by this LCD and this side by this LCD. So here, we're going to multiply by x plus 1 over x plus 1, and here, x plus 3 over x plus 3. This way, what we're going to do now is we're going to multiply through. So we're going to get 2x squared plus 6x plus 6x plus 18 once we FOIL this. When we FOIL the bottom, we're going to keep the denominators the same. So we're going to keep the x plus 3 and the x plus 1 in parentheses. We're going to do the same thing to the other side. We're going to multiply through on the top and FOIL out. So we're going to get 2x to the third plus 2x squared minus 2x minus 2, and then we're going to do that same rule where we keep the LCDs on the bottom. We're going to keep x plus 3 and x plus 1, sorry. Now we're going to add our terms together on the numerator to get our final answer. We always keep the denominator the same in a function operation. So our final answer is going to give us 2x to the third plus 4x squared plus 10x plus 16 over x plus 3 and x plus 1. We got our numerator because we combined all the terms on the top. Now, this is our final answer, but we still need to find the domains. We're going to equal both of these to 0. We got x plus 1 equals 0. We're going to subtract the 1 from both sides, and we know that x cannot be equal to negative 1. We'll do the same thing here. X plus 3 equals 0. Get rid of the 3, and we get x cannot be negative 3. Now that we did addition, we're going to try subtraction. F minus g of x. We know our f of x and our g of x are given above, so we're going to plug it in. F, 2x over x minus 2, is here. We know our g of x is x squared minus 4 over x, which is here. We're now going to subtract them. Our next step, now that we've already set up, is to multiply by the lowest common denominator, just like we did above. So here, we're going to multiply by x minus 2, and here, we're going to multiply by x. This is because we want to get the lowest common denominator on both sides. Now we're going to do what we did before. We're going to multiply through, but leave the denominators just as they are. So here, we're going to get 2x squared over x times x minus 2 minus x to the third minus 2x squared minus 4x plus 8 over x minus 2. Now, we're going to distribute the negative. Keep the first part the same, 2x squared over x times x minus 2. We have a negative here, but we're going to distribute it here. So we're going to get minus x to the third plus 2x squared, because a negative and a negative will create a positive, plus 4x minus 8 over our common denominator of x times x minus 2. Because we distributed this negative, what we're going to do now is combine like terms. So we're going to get, when we bring the 2x squared over, is because we're subtracting, these two are going to cancel out. Our final answer is going to give us negative x to the third plus 4x squared plus 4x minus 8 over x times x minus 2. Now what we need to do is we need to find our domain. Because the denominator is x times x minus 2, we need to equal it to 0. So x minus 2 equals 0. We add 2 to both sides, and we get x cannot be 2. Now we're going to do multiplication. F of x is equal to 2x over x minus 2, and g of x is equal to x squared minus 4 over x. We're going to multiply f times g. So we multiply f and g as given above. First, what we're going to do is we're going to factor out this x minus 2, x squared minus 4. So we're going to get 2x over x minus 2, and then we're going to factor. We know that this is going to equal x plus 2 and x minus 2 over x. Our next step is that we can now cancel things out. We know that there's an x minus 2 on this numerator and this denominator, so these will cancel. We also know that we could cancel other things, like this x and this x. We now can conclude that our final answer would give us the simple answer of 2x plus 2. Now that we have our final answer, we need to find our domain. We're going to equal x plus 2 to 0. Subtract the 2 from both sides, and we know that x cannot be equal to negative 2. That is our domain of this problem. Now we're going to do division, f divided by g of x. We have our f of x is equal to 2x plus 6 over x squared minus 1, and our g of x is equal to x squared plus 5x plus 6 over 3x plus 3. We set up f divided by g. What we're now going to do is in a division problem, you have to flip the second fraction and then multiply as you would. So here's what you're going to do. Keep the numerator the same, 2x plus 6 over x squared minus 1. And now you're going to multiply because you're flipping the second half. 3x plus 3 over x squared plus 5x plus 6. Now what we're going to do is we're going to factor. We'll keep here 2, and then we'll see that we can factor out x plus 3 over, we can factor out the bottom, x plus 1 and x minus 1. Now we're going to check if we can factor the other side. We can. 3 times x plus 1 over, and when you factor out the bottom, you'll get as your answer x plus 3 and x plus 2. In division, there's a third domain sometimes. First, we'll plug in normally. X plus 2 equals 0. We subtract, we're going to get that x cannot be equal to negative 2. Now we're going to go here. We're going to plug it into these domains. X squared minus 1. When you factor that, you're going to get x plus 1 and x minus 1. Therefore, we can conclude that x cannot be equal to positive or negative 1. We're now going to plug into this, x squared plus 5x plus 6. We're going to get, when we have x squared plus 5x plus 6, and we factor that, we're going to get x plus 3 and x plus 2. When we set them both equal to 0, we get that x cannot be equal to negative 3 and x cannot be equal to negative 2.
Are there any other function problems?
Now we're going to try with a radical. We know that f of x is equal to x and g of x is equal to rad x plus 1. What we're going to do now, if we want to do f plus g of x, is we're going to do x plus 1. We're now going to equal this. X plus 1 is greater than or equal to 0. We're going to subtract the 1 from both sides, and we're going to get that x is greater than or equal to negative 1. That's your new domain.
Thanks for teaching me math, Love ya.